You might have seen an infinite nested square root, but have you seen an infinite nested cube root? In this video, we're going to calculate this infinite nested cube root of 1 plus the cube root of 1 plus the cube root of 1, where the cube roots are kind of nested. They're inside each other and cascade. What on earth is this number equal to? We're going to find out in this video. So the trick that's sort of standard with this, but it's really beautiful, is to set this equal to x. Okay, we don't know x, just like in algebra, we're trying to solve for x. And what we can do is we can try to solve for x. Okay, so in math, it's always good to try to make some progress and see where it goes. You know, it may usually get closer to the solution. So we cube both sides, and then we get 1 plus the cube root of 1 plus the cube root of 1, etc. We've just deleted the outside cube root. If you cube both sides, that's equal to x cubed. Okay, so that's pretty cool. Okay, so we basically got this is equal to x cubed. And what's so beautiful about this is if you actually notice what we have left here in this infinite nested cube root, it is actually just x, right? Because we have an infinite number of these cube roots. You delete one, you still have an infinite number of these cube roots. So this quantity is literally just x that we see up top. So we get 1 plus x is x cubed. Okay, so that's our equation, that 1 plus x is equal to x cubed. And that's what we want to solve. How do we find x? Okay, so another way of writing it out, if we put everything to one side, is it's the same as saying that x cubed minus x minus 1 is equal to 0. And that's what we want to solve. Now, solving such cubic equations was a great mystery in math. It was really a very ingenious discovery. How do you find solutions to these? And I'm going to explain to you how elegant it is, okay? But just for the time being, I'll give you what the solution is, and then I'll explain to you a very beautiful way. So make sure to watch till the end for that to understand how to solve this. So we're trying to solve x cubed minus x minus 1 is equal to 0. And this is what is called a depressed cubic. And by the way, don't forget to smash that like button if you're enjoying the content. Okay, there's a lot of suspense coming up, and be sure to subscribe for so much fun math content. I really love making this video, and I'm so happy that you're watching right now. So let's now try to figure out how to solve what this is called a depressed cubic. So depressed cubic is basically a cubic equation of the following form. So I'm going to write it out. It's something like x cubed plus px plus q is equal to 0. And why it's called depressed is not because it's sad or anything, but because it does not have an x squared term. Okay, the x squared coefficient is 0, and this is the first step. You know, solving these is the first and main step to solving all cubic equations. So as I'll explain, you can convert any cubic equation to one of these forms. So that's a little nice trick. The roots of this depressed cubic have the following form. So what we can do is we can take this quantity. Okay, so we can take this quantity which we call q squared divided by 4 plus p cubed divided by 27. Okay, this quantity, we look at this quantity, and what we're going to do is we're going to write the roots of the equation in terms of this. So the roots of this equation, so the real root, okay, this is going to have, in our case, it's going to have two complex conjugate roots that are not real and one real root, but the complex conjugate roots can be discounted because this is, you know, if it exists, it's a real number, okay? So, but what we can do is you can write this form. So the real root is going to be the following. It's going to be the cube root of minus q over 2. So it's kind of like the quadratic formula, okay? Very roughly like the quadratic formula. So it's going to be minus q over 2 plus the square root of q squared over 4 plus p cubed over 27. So that's the first term, plus the cube root of, again, minus q over 2, but this time minus, okay? So minus the square root of q squared over 4 plus p cubed over 27. Okay, so this quantity is actually, if you multiply it by minus 108, you get what is called the discriminant. Just like that b squared minus 4ac in the quadratic formula, there's this thing called the discriminant, and this is going to be a real root so long as this quantity here is actually a positive number. Okay, so then you can actually take the square root and get a real number, and this expression will be a real number. So as long as what is called the discriminant is negative, because the discriminant, remember, is minus 108 times this. So if the discriminant is negative, you have this one real root and two complex conjugate roots. So I'll explain how that comes up, but now let's actually use that formula to write down the solution to this problem. So in our problem, we're just going to get that q is going to equal to -1 and p is going to equal to -1, right? Because those are the coefficients of our original depressed cubic. So q is equal to -1 is equal to p. So now we can actually just plug in and find this number, which is going to be so beautiful. So we're going to get cube root of minus q over 2. So what's minus q over 2 is going to be half, okay? Because q is -1, and then we're going to add on the square root of q squared over 4 plus p cubed over 27. So it helps just to figure out what that is. So q squared over 4 plus p cubed over 27 is just going to equal to the following. It's just going to equal to 1 over 4 minus 1 over 27. And if you make a common denominator, that's 23 over 108. Okay, so that's pretty cool. 23 over 108. So we're going to get this plus the square root of 23 over 108. And then we're going to get plus the cube root of, again, half minus the square root of 23 over 108. Okay, so that's what we're going to get. And this is very roughly equal to 1.3247. Okay, that's what it's roughly equal to. So it's a pretty cool number, and that's the solution. But how do you actually find this nice expression? So check out this video. It's going to pop up on the screen here. It's a beautiful and elegant, just literally 5 minutes. Okay, watch that video. It's a 25-minute video, but the first 5 to 10 minutes explain how to get this elegant formula, and it's so beautiful. You just got to see this. Okay, they don't teach this in school and college. And another video is, why is this number even a number? You know, we set our x equal to this thing, but how do we know this thing even makes sense? Check out this video.